What's up, guys? Welcome to another video. Today we're going to be playing some PC building simulator. This is the first version, not the second. The reason I'm going to be doing this is because, well, like the title says, I want to teach you guys how to build a PC. I pretty much went through this myself. As you guys can tell, this is not pre-built. I actually built this myself. I did like 3 to 4 months worth of research, and then I bought all my stuff individually just to wrap my head around like what was working with what wasn't, etc, etc. And then my final product is here, and this is how I'm able to make these videos. Very proud of myself. It's really not that hard at all. The biggest misconception about building a PC is that it's just confusing. And I get it. There's wires, there's voltages, there's like frequencies, there's all this different stuff that just doesn't make sense. But right now we're going to teach you as far as I can, really. Again, I'm still kind of like novice beginner to this. I barely understand what megahertz is, gigahertz. I do understand that they're a frequency and that the higher it is, the faster it goes, the lower it is, the slower it goes, and also it does decrease range. But for this video, I really wanted to just really break down just the simple components, what you need for the PC, what wires you really need to know. Again, when I did build mine, I built mine strictly off my knowledge. Every time I didn't know where something would go, I would either refer to the user manual on the Gigabyte website, because I do have the Gigabyte Aorus motherboard. So anytime anything like that happened, I just Google that. If I couldn't figure that out, just go straight to YouTube, type in the motherboard I have, and see what goes to it. And before the video starts, I really want to give a big shout out to pretty much everybody here on the channel. My videos have been getting a little bit more views and a little bit more interaction, and I very greatly appreciate it. It makes me want to make videos more. If you guys will, please give a like and subscribe to this video here and this channel, and leave a comment down below on this video to let me know what you guys also want to see. Even though this is still the birth of the channel, I will want to do various things, and eventually we will find something that works, and we'll just continue to rock with it. Without further ado, here's that video. Again, like, subscribe, share the video. I'll see you guys next time. Peace. All right, so this is PC building simulator. I'm pretty much just going to teach you guys how to build a PC right here. I didn't use this to build my PC, but I really wish I would have. We're going to go ahead and enter free build. I did have a new game already played. I just made like an Asus case. What we're going to do is we're going to go into continue, and then we're going to actually dismantle that PC I built, and then we're going to go ahead and walk you guys through it. So here we go. All right, we're going to come right over here to our inventory, and we're going to go ahead and look at all this. So before we build anything, bro, before we get into anything, we're going to go through this pretty much list from what you need first to last and what exactly it does, what they mean, all that good stuff. So first off, thermal paste. You absolutely need thermal paste. It transfers heat from your CPU to the fan, your cooling system. The thermal paste goes on directly on the CPU die. USB drives, you use USB drives for literally anything. I used mine to actually install the Windows OS so that my PC could run. OS is pretty much just like the thinking system of the computer. And compressed air, you know, just clean. I actually bought some from Office Depot because I have a cat. CPU and processors. So CPU is the processor. CPU stands for computer processing unit, I'm pretty sure. So CPU is the processor. There's pretty much only two sellers of CPUs. It's Intel or AMD. I will say AMD is better for gaming, like this Threadripper's crazy, but Intel is better at kind of multitasking. Based on other reports like Gamers Nexus, check out the description below, they probably would say that AMD and Intel are pretty neck and neck at the moment for both either gaming and just normal processing power, whether it's like editing and recording and playing games or just playing games. So AMD and Intel are both kind of head to head right now, but I am an Intel fanboy. I do prefer Intel, so we are going to go with Intel. On top of that, we have stuff like the series and the socket and the frequency and cores. When we go to series, we have all of these ones pretty much in that order, least to greatest. I currently run an Intel Core i5 13600K. So the K stands for unlocked. So this one's an Intel Core i5 7600K, which basically means it can be overclocked. Overclocked just means this frequency here, the 4200 megahertz, it just means you can go above that to make the processor speed up so that it's working faster. Socket is just the series pretty much. Before I skip over that, the only way I can really equivalent this to is if you wear Vans, Intel would be Vans, and then the authentic would be the i5, the old school would be the i3, and so on. Okay, and then when you bring out certain colorways, that would be the 7600, 7500. Okay, but the sockets, these are going to be your sizes basically. If you wear a size 8, if you wear a size 9, and this is going to be, does that the parameter of the die fit on the motherboard? Will it sit in the socket well? And then frequency. So frequency, just like I'm telling you, it's all this stuff. You can make it go faster, you can slow it down, whatever. It has a base gauge. The cores are the biggest thing. Cores are broken up into halves. There's always going to be halves. So if there's 4 cores, that means 2 are performance, 2 are efficient. Performance is exactly what it says. It's going to go towards performance. So if you're gaming and stuff, it is going to pitch in a little bit. If you're doing really anything that your graphics card and your CPU are both going to be interlocking with, then it's going to provide some of that support. The other 2, the efficiency cores, are going to be when you're running like apps and stuff. You can actually change the frequency on both the cores. So if you want E cores, efficiency cores, to run faster so that it's more efficient, you can. Same with P cores. Again, I'm kind of just summarizing this just so you guys kind of understand, you know. CPU cooling comes in 2 different ways. We have here, which is the traditional big radiator with a fan, or a big radiator with 2 fans, kind of like a push-pull. So you're pushing air in and then pulling it into your case, okay? Those are usually, they work really well. It's just a lot of fans and stuff, and you don't always have the ports on your motherboard. Or you have custom water cooling, which is going to be like a fan and tube. You can do that. It's probably honestly better, but it is more expensive. It's a lot more work. You got to get like acrylic tubes. You either got to pay someone to do it. It's a lot of time and work. It's cool though at the end. The third option would be an AIO. It just stands for all-in-one. So it has the radiator and the fans, and it has 2 tubes going to a water pump that you put onto the motherboard. And essentially when the CPU generates the heat, it's going to go to the thermal paste, and then the thermal paste is actually going to go and transfer it to a copper plate on the bottom of that water pump. And the water pump, since it's swirling, is going to really cool it down and transfer heat. Okay, so these are AIOs, radiator on the back and 3 fans. Okay, and then this is the water pump right here. This sits on your die and actually cools it while the water runs through these tubes and in a loop. Okay, it's a closed loop. Here is the airflow. 160 CFM is basically how much air it's going to be sucking in or pushing out. In this case, since it's cooling your CPU, you want to be sucking it in. So the higher the number is, basically the better it is. That's pretty much all for cooling. It's pretty simple. Hopefully I didn't graze over anything. All right, so motherboards. Motherboards are like a lot of information to go over. So let me see how I'm gonna do this. As you can see here, you have A, B, H, T, X, and Z. The lettering of your motherboard is gonna determine what you can do with it. B's are pretty basic, and A's. H's are kind of in the middle, or A's and B's are like the lower tier. They can't be overclocked. Minimal IO ports. IO ports are going to be stuff in the back of your PC, like your HDMI cable, your peripheral connections, all that good stuff. Some of them don't even come with IO shield. X's and Z's come with IO ports, a lot more IO ports, and a lot of them already have the IO shield installed. The next biggest thing about motherboards are going to be your form factor. It's the shape, width, length of your motherboard. So it's just how big is the motherboard. That is the form factor. The memory is going to, these are what's going to go in your DIMM slots or your memory card slots, whatever you want to call them. Minimum you want 16, but with the way gaming is going now, you probably want to go to 32. RAM is in charge of remembering sequences on your computer. So when you open up a game, when you open up an app, it's the first time you open it, it might be kind of slow. The first time you start up your computer, it might be kind of slow. So this is in charge of pretty much remembering everything your computer does, all from starting up, opening apps, how things are functioning. Depending on how much you have of gigabyte, it's going to determine how fast it really does that and how efficient it is at that. You can only pair 2 of them together. I recommend 2, not 4. 4 is really, if you really need all of that, it's probably a total of 128 gigabytes that you can have, maybe more on a PC. But unless you're doing like some crazy computing power, you really don't need 4, bro. 2 is perfect. 2 is fine. 2 is the golden number for this. Okay, right here we have DDR4 and we have the frequency. So RAM type, DDR4 is just a generation. The same way the PS4 is last generation, the PS5 is now generation. DDR4 is last generation, DDR5 is now the new generation. Your RAM is going to determine what kind of motherboard you get and what kind of processor you get. Just because if you get a DDR4 motherboard, you can't have a DDR5 because it just won't run. So that's basically that. Like, that's all RAM does. So graphics cards are, right now in this day and age, are crazy, bro. They're so powerful. They can do so much. So the biggest things you want to look for is the chipset brand. So you only have 2, AMD and NVIDIA. There are a lot more manufacturers coming out. Again, this is just an old version. I personally have NVIDIA because NVIDIA is actually great with their video encoder. Basically what that means is that it's just the GPU will do more of the processing power for video and editing software and stuff like that rather than your CPU. AMD is really good for gaming in my opinion. If you can get a good NVIDIA GPU, I highly recommend it. In connection with your RAM, this is also going to help your game a lot. Depending on how much VRAM you have is how well your graphics are going to hold on the game. This is going to determine whether you can play on high, ultra, low, medium, whatever it is. The more VRAM, the better. I know on AMD, some of them have 12, 16. But again, VRAM, you want more VRAM because it's going to better suit the graphical needs of your game. Sometimes people side mount these so that the fan is going against the glass or whatever. It's usually glass or the case. I don't highly recommend it because it's not getting any air in between there. It is a good, it's good aesthetic. It looks really cool. But GPUs, they're pretty simple. They're the simplest part of anything. You literally plug them in, you're done. You don't really have to touch any of it. So this right here is storage. Exactly what it sounds like, guys. Storage. All of you guys have saved pictures to your phone, pictures to your laptop. You know, all done homework. You've all done school computer type stuff. So we all know what this is. The only thing is, what is HDD and what is SDD? This one's a big bulky thing. You know, the other one is going to be an SSD. It's a solid state drive. So this one's going to be a less vulnerable. Usually it has better speed. So transfer speed, it basically means how fast can I download to this or how fast can I upload from this. Hard drives are really good for, these ones are really good for if you're taking a lot of pictures, taking a lot of videos, just you want to be like a file whore. The other thing, which I have, is the M.2. This is basically the newer type of SSD. They're a lot faster and they can hold a lot of storage. I highly recommend NVMe's M.2s because of how fast they are. I mean, like 3250 megabits per second, by the way. That's really good. Really only recommend hard drives if you're going to be saving a lot of pictures, videos, if you're somebody like me or like a photographer, videographer, stuff like that. The power supply, this is pretty much your heart of the PC. Without this, you cannot do anything because again, it's the power supply. So the type, it could be modular, non-modular, semi-modular. So modular just means that your wires and stuff, you can move them around. You can take them out and you can move them all about. Non-modular means that it's already set. Like it has this big ass thing, the wires in there, you have to take it all in, it's one piece. And then you have semi-modular, which is some of them have some cables and then the other rest of it is permanent. The wattage is super important. What's going to determine how much power you need? The easiest way to find out which one you need, go back through whatever you're grabbing, check out how much wattage it is, and it's simple addition. I personally like to give myself at least 100 more watts than what is actually needed. That way I know for a fact I am not going to be shorted on my power because I don't want to be recording or playing games and maybe there's a power spike and everything just shuts down. But again, power supply is super simple. All right, and last but not least, we have these three categories: cables, cases, and case fans. So cables, at least on the game right here, it doesn't really matter. In the game, when we actually start building the PC, I will explain what the cables are and what they do. Cases, super simple. The case you want should be airflow. That way you have no overheating, all your fans get enough air, everything's being cooled, and everything's running perfect. You can have something with like a lot of glass like this one here and it has maybe the side slits. It's not going to get the best air, so it might be a lot hotter, which is going to make your fans run a lot faster, which is going to mean a lot louder noises. Case fans are going to be just the same thing as the CPU cooling. It has the CFM and the size. You just go ahead and screw this into your PC and you have some case fans, and that's going to help cool things down a lot. All right, time to get into the juicy part. We're actually going to start building the PC now, okay? So we're going to go back onto that list and we're just going to go straight down the line. From here on out, I'm pretty much just going to say what I'm grabbing, why I'm grabbing it, what it does, where it goes. You have to choose the motherboard because we have to put the motherboard in there first and then the PC and then the CPU. So that's the one we're going to go with, the Aorus Ultra. Mine's the Aorus Elite, so it's pretty close. So let's get our case going. Again, you want some airflow. This one looked really good. Oh yeah, this is the perfect one actually. And you guys can see everything right here is perforated. These holes, it's all perforated. It's a completely bare PC, okay? This is exactly what you guys are gonna be seeing. I would say if we're gonna put case fans, usually you want the top ones to be exhaust because heat rises. You want some in the front to push air in, and you want one in the back to exhaust it. In, exhaust, exhaust. What I'm putting in right now are called the studs, I believe. They're basically going to be like these little pins that hold, that the motherboard sits on, and then you put screws in them to hold it down, which is going to be all this stuff right here. That is the first step. Now, usually when you get your PC, I highly recommend you not to put in your motherboard first. You should take out your motherboard and literally put every component that goes on the motherboard first, which is your RAM, your GPU, your CPU, maybe your graphics card, maybe a video recording card, whatever. So right here is your CPU socket. This is your DIMM slots. This is where your RAM goes. Your RAM goes here, usually in this one and this one, or this one and this one. Never all four, unless you're doing something crazy. Down here, this is gonna be your audio codec, but I do prefer to have good audio. The next step is going to be the CPU. And we'll do this one, the i5 9600K. When you do start to install your stuff, you're gonna wanna open your CPU shield just like here, and you just install it. Super easy. You'll just go ahead and, for at least Intel, you literally just grab it and drop it. You never want to push it in or anything, because these little pins right here, they can crush. One little one, bro, and you're fucked. There is nothing you can do about it. And then you close it, and you always want to put that little bar down. So the next thing we want to do is we want to find some RAM. Go to memory. We're gonna go ahead and put the Vintage Pros 3600s in, because they are what I have currently, and we're gonna put 2 in, which is 16, even though I was gonna get 2 16 ones to put in for 32. We're gonna put them in DIMM slot 1 and DIMM slot 3, which is usually pretty common. So there's that first one, and then we want to install a second one. Boom. And usually, again, same thing, you want to hit these little clips and they'll open just like that. And then when you put the RAM in, you want to be careful. Again, there's like little notches in there, and as you can tell, I actually can't see, but right here, that's little notch right there. You put it in there and it'll click, and these will pretty much close automatically. So don't force it in, you will break it. Next thing we want to do is put in our CPU cooling, because now that we have the RAM in, if any one of these are like too big, we wouldn't have been able to put the RAM in. So sometimes they are really big, but we are going to go water cooled. We're going to run the Pro, because why not? We're gonna put it front mounted. The only thing about doing front mounted is you want tubes down. Yes, you want tubes down. I mean, this is still good, but you never want the pump to be higher than the tubes. So we're gonna go ahead and screw these in, and that's that. You literally just put your CPU, your cooler in, whether it's gonna be here or here. And this is going to be intake, so it's going to be cooling this off, which means this is going to be exhaust. So it's going to be sucking air through here. So we'll go ahead and install that dust filter, because you don't need it anymore. And we could probably put the front of the case on now. So boom, we're pretty much, I want to say like 25 to 50% of the way done already. The next thing we are going to be putting in, which I believe is going to be the next important thing, is your GPU. Remember, we're going to choose this one because this is the one I have. So this one's actually going to be, it looks like I can either side mount it or just normally mount it. So I don't want to side mount it, because, so this is side mounted. And when I put it in the front panel, look at that. So I'm getting air from here and here, right? But this thing is getting no air. So these fans are sucking in a little bit of air that's squished up against this window. That's not what you want. This will overheat. Maybe not crazy, but it will overheat, and you probably just will end up getting some shitty shit. So what we're gonna do is we're gonna install it right here in these two DIMMs and these two PCIe slots. So this is what it looks like more traditional when it's just normally mounted. To me, this is the perfect way to do it, because since the air is coming in through here, it'll wrap through here, and it'll be sucked in through here, and it'll come out, and then it'll be go through the top and through here. I think this is the ideal way to do this. Next thing we're gonna do is we'll do the storage. This is a perfect middle ground. So it'd be the 64 gigabyte, and then we turn this around. All this stuff goes pretty much in the back. Every computer basically has these trays. We'll go ahead and put remove. You open them. You can have 2, you can have 1. We're only gonna install 1 because we don't need 2 in a video game. So you install it right there, and then we're gonna go ahead and close it out. We're gonna close it, close the drive bay. Again, we're not plugging anything in just yet. So we've got we got our storage, we've got our GPU, we got our CPU, we've got our RAM, we've got some cooling. Okay. The next thing I do believe we need going to be the power supply. Well, before we do power supply, we should get CPU fans or case fans. That way we know how much wattage we're going to be using. And we're just going to go with, actually, I have these actually on my, these are going to be these ones. I have these exact fans on my shit. So we're gonna put one here. Usually I would have 3 up here because I can fit 3, and it'd be another 360. But right now this is going to be exhaust. So this is going to suck up all the air in here and throw it out the top here. We're also going to add another one here for an exhaust. Don't put that there. I love RGB, so it has to be RGB. So with all these case fans, the DIMM, the CPU, the radiator, the GPU, and the hard drive, so far we are, I want to say, bro, we're like 90% done. We're almost there. Next thing I want to put in is that power supply. Okay, I'm just gonna go ahead and get a 1000 one because I'm not gonna count all these wattages, but I do recommend you do that. So it's just the RM1000 I'm gonna put, and it's modular. I love this one. So that goes down here, and then you have your shields that you put on. So you're gonna screw it in and plug it in. Right now we're not gonna plug it in though. But looks like other than that, I mean, you're pretty much done. I mean, we have the CPU, we have the cooling, we have the motherboard, we have the memory. We just put in the graphics card, put in both storages. Now for cables, at least right here, nothing too crazy, but we're gonna choose some tight ones because nobody likes loose cables. All these little connections down here is what all of this is gonna really connect to. Mostly this right here, your hard drive, your other SSD, and then like this will connect to it, these will connect to it, this will connect to it. I will say pretty much almost every motherboard has this configuration. Because the game doesn't label any of these and it's just highlighted, I can't really go over it, but I do know that this is the exact same place. This is actually going to be the power. This is going to connect, so we're going to have to do it now. This is going to connect right here to the back of your PSU, and it's just like that. It's going to run through there, and now you have power to your motherboard. That is the power cable to the motherboard. This is going to connect our pump, the knowledge, how fast everything's spinning, when we need it to spin, why we need it to spin, all that information. So this is going to connect to that. This is also motherboard type stuff. So this is going to go to your, this is also going to give more power to your motherboard right next to where the other one went. The next easiest thing to plug in is your GPU because it's only 2 connections, sometimes 1. It's never more than 2 actually. I think sometimes I saw 3, but you plug them in here and you go straight to your PSU. And again, I would say what these are labeled, but even on your PSU, it's gonna be labeled, like on these bottoms, it's labeled PCI 1, PCI 2, or all this other stuff. And again, it's just a quick Google search to see how to do it. So right now it's asking for all these fans to be plugged in. Okay. Oh, so this is the case. So this is the power button up here. Okay. So you guys see the power button right here. We have to connect that wire to the bottom right here, which is a USB connection. That's going to let us have this wire, which gives us power to the motherboard, which gives power to that cord, which gives power to the whole case. So that way we can press the button. We're going to connect our SSD and our HDD because again, super simple. It has only 2 connections. It's going to have one SATA and one to your USB. So usually you can put them on the bottom. And then the other connection will be your SATA connection, which is going to give it power. Again, same thing for your HDD. It's going to be a USB, go to your motherboard, and you're going to bring it back, and you're going to have a SATA cable. It's thin and flat, and you're just going to plug it into another power. Even here, you can kind of see that it's flat. It's at a 90 degree right now. But you're just going to plug it into the back of the PSU. Pretty much all I have left is our fans. Fans just go straight into USB motherboard headers. Like this one, it looks like you can daisy chain them. Daisy chaining just means you're gonna connect wire by wire, or in some cases magnetic like mine, or notches. You're just gonna connect them to each other so that the power is running to all 3 of them through one cable. So this is connected to this one, and this one's connected to this one, which is connected to the power. So when the power runs through, it's gonna go through here and power all of these up. My cat just jumped in the middle of the frame. You guys can see your tail. But other than that, bro, we can pretty much put all this together and it should turn on and we'd be good. But like I said, all the cables that we just put together are very, very similar on every PC across the board. If you just follow this simple stuff, like literally, I'm sure you could use this as a guide to build your PC. If you don't want to, you don't want, like feel comfortable, I do highly recommend people like Gamers Nexus. I'm gonna put all this stuff in the description to help you guys, but this is how that's how I learned from those videos and those guys. Hopefully you guys can learn from me, you know, stuff like your RAM, your CPU, your cooler, your GPU, your PSU. Those are all important. Those are the most important things. If I had to break it down, I think 7 of the things you need just to make a computer work is CPU, GPU, air cooler, RAM, motherboard, PSU. It's really just those 6 things I guess you need that are like essential to make your computer run. Everything else, like these case fans and stuff, extra, but it does help cool this down and cool that down. Okay, right, gang. So with the computer basically completely rebuilt and put back together, this is what our final design looks like. It's not the prettiest, also not the best. However, this is a complete build. I did throw in the USB because we do have to put in the OS. Just like I said, I used my USB to put in the OS. It's super simple to put in OS. If you just look up installing Windows 10 through USB, you'll be able to find it. I have no idea what my cat's doing right now. If I did everything correctly and I walked you guys through this correctly, and the game technically walked me through this correctly, this will turn on and we will be able to turn on the OS. So we're gonna go ahead and press the button. And it started right up. So you guys see, everything's working. Looks absolutely amazing. This is, damn. That's Motherboard's actually super sick with this right there. That is how you build a PC. So hopefully you guys did learn something from this video. This was really fun to make, actually. I love this game. I love building PCs. If you guys want me to build a PC for you IRL, just throw it to me. I'll go ahead and build it for you. If you want to get the parts, you can get the parts. If you need help recommending parts, I can help you recommend parts, or I can recommend you parts. But yeah, that's pretty much how you build a PC. Hopefully I didn't go too fast for you guys and confuse you or anything like that. If I did, I highly recommend just playing the video back and really just paying attention to what I say. I know I spoke really fast. I'm still trying to get used to talking on camera and really setting a tone for these. But I also was really excited to make this video. I love building computers. There's also a lot of information that I probably left out or just skimmed over. This was a big summary and really just an introduction to show you guys how really uncomplicated it is. Like, you can really just walk into it and start building your PC. I know a couple of friends who literally just bought theirs either pre-built or built it, and it's great. They love it. And when you have a PC, you're solid for maybe 10 to 14 years, I want to say, whereas a console, you are also as good for 10 years though, maybe less. I mean, the PS4s compared to the PS5, I think it was a 10-year jump, maybe more, 13, 14. And it's just because technology is always advancing and all this stuff behind the scene. But the best thing about the PC is you don't have to wait for that next gen. It's always, every 2 years, there's new technology coming out for computers rather than consoles. It's just, I think it's because Hooke's law, Moore's law, or something is going to be probably here on the screen. I think it's, I learned about this in computer science, but every 2 years, technology jumps up twice as fast, twice better, and it's always getting better. So when you have a PC, at any given moment, you literally can upgrade and be an extra. So right now, I just built mine. I'm probably set for the next 10 years. If I wanted to upgrade to the 1400K, I would be set for another 10 years probably, just with the CPU alone. And my GPU would still probably be good. It's a 2080 Ti, still very heavily used, and it's running great. If the GPU were to give out, if it's not another 10 years, then it's probably another 9 years, 7 years max. So that's 17 years. I could just have this PC with only changing 1 or 2 components instead of having to buy a whole new system. Then again, it is more money because the components could be expensive, but again, it is worth it because of the longevity, at least in my opinion. And you get the option to play every game in the world instead of what's just exclusive to your game or what just happens to be crossplay, you know. That's my own opinion. But if you guys did enjoy the video, please make sure you guys give a like, leave me a comment. It looks like my cat is getting ready to jump here. I don't know if you guys can see her. What's up? Actually, this might be the thumbnail. Come here. Hopefully you guys enjoyed the video. Make sure you guys like, subscribe, comment down below. Check that description, please. There is a lot of useful information I'm going to be putting down there. Everything from links from my socials all the way to these people that I actually learned to build this stuff off of. So if you guys are interested, please check out those channels. Please, 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 please. Because I don't want to be the sole reason you guys build a PC and then it blows up or it doesn't work. Coming from somebody who built it blindly, and then playing this game, like it really is very accurate. So I really highly recommend you guys to watch this video back and watch the people I put in the description. Please and thank you. But without further ado, I will leave you guys to the rest of your day. If you guys want to reach me, please check out those links in the description, and I'll catch you guys later. Peace.